Hello, this video deals with a probability density function, and this is in the area where probability and calculus fall in line and work together. We have a function who is a probability density function. You don't have to go check it. Its total area under the graph is equal to 1, and it's always a positive function. The question we are facing here is to find the mean. All right, the average value, the expected value of this function. There's a formula. And the formula is that your job is to integrate the function multiplied by x. This is reminiscent of finding an average of numbers. You take the number and you multiply, you total up. The totaling is the integration here. And you multiply the number times the probability of it happening, sort of. That's what's going on here. This formula, it's like a center of mass formula, reminiscent of the moment about the moment about the y-axis. Here we go. So for us, the integral goes from minus infinity to infinity to start out by definition. In our particular function, though, our function is only non-zero when x is greater than or equal to 0. Our function is 27 over 16 x squared e to the negative 3/2 of x. And so the bounds then are from 0 to infinity for us. And multiplying the x's together, we get x cubed. So it's our job to tackle this integral. A polynomial times an exponential. We can use integration by parts, but we can use the shortcut. What's the shortcut? Well, it doesn't always work, but it does work when you have a polynomial times an exponential. It works really well, especially if the polynomial is of degree 2 or higher. If we were to actually do this question by formal integration by parts, we would have to do 3 different integration by parts. Take it down from cube to square, from square to x, from x to the constant, and then we'd be able to integrate. Too much work, so we have a shortcut. And the shortcut works when you have a polynomial times an exponential or a polynomial times a trig that you can integrate. What is the shortcut? Well, let me just give it to you quickly. There's steps to it. Step 1 is to differentiate the polynomial down to 0. And at the same time you do that, you want to move to step 2, which is to integrate the exponential or the trig the same amount of times. And then you're going to multiply along diagonals going down and to the right and apply an alternating sign, starting with the plus. And so that will do it for you. It will do all the UV minus VDU and the double minus on the second time through. It does it all for you. And so let's see that in action on our integral. The 27 over 16, pull that outside. Focus on this x cubed and this e to the negative 3/2 x. We're going to take it, and step 1 is to take the derivative of the polynomial down to 0. Step 2 is to integrate the exponential the same amount of times. So x cubed is our polynomial. So 3x squared, 6x, 6, and 0. Take the derivative of the polynomial down to 0. Now when it comes to integrating, it's e to the negative 3/2 of x. Anytime you integrate e to the kx, what you get is 1 over k e to the kx. So the reciprocal of whatever is up in the multiplier on x comes down in front. So the reciprocal of our negative 3/2 is negative 2/3. Don't change the sign or anything like that. Just keep the same sign. So first time we get negative 2/3. The next time we'll get another negative 2/3. So that'll be 4/9. And then another negative 2/3. So that'll be a negative 8/27. And then another negative negative 2/3. And that would give us a positive 16 over 81. Okay. What do we do in step 3? We multiply along diagonals going down and to the right. And on this product, we assign an alternating sign. It does all the UV minus VDU for you, integral VDU. It does all that for you. And so it'll be x cubed times the negative 2/3, e to negative 3/2 x, then negative 3x squared times the 4/9. So let's put this together then. We can do some canceling with those multipliers. The 3 can turn the 9 into a 3. That's how we get negative 4/3. The 6 can turn the 27 into a 9, leaving you with a 2 times the 8 to give you the negative 16/9. Same thing here. 6 can turn the 81 into a 27, but leaving you with the 2 to double up to 16. That's how we get those guys there. Everyone happens to be negative here. As I'm doing it, I'm recognizing that this e to the minus, 3/2 x, of course, is on everybody. So it's kind of like kind of like factoring that out. And when you have the improper integral, it's great to have that all in the denominator, negative exponents. And so I kind of factor it out and put it in the denominator of everybody. And now we're going to plug in the bounds of b and 0. Still got that 27/16 on the outside. And we're going to take the limit as b goes to infinity. You put the b in, and b's replace the x's. And then you put the 0 in. And all the x terms go away. You're left with this constant in the numerator. And then e to the 0, that's just a 1. Be careful with that double minus too, as well. So, so there we go. And it's our job to figure out what's going on as b goes to infinity. And so we can't plug in infinity, but we can think about a very large number. Before we do that, we're going to distribute the 27/16 and simplify the part where we plugged in 0. See this part here where we plugged in 0? The double minus gives me a plus. The 32/27 is over a 1. And then this 27/16 is coming in as a multiplier. Of course, that's going to cancel and give us a 2. And it's our job to show that this limit, as b goes to infinity, is going to end up going to 0. We don't know it for sure. We have to show it. Can't just say it. Perhaps you might be allowed to do an argument based on the growth rates of a cubic versus an exponential. If your growth rate in the denominator is larger than your growth rate in the numerator, you could say it goes to 0. But I kind of like to show it in a rigorous kind of way. And so we'll use L'Hopital's rule. We'll have a negative infinity in the numerator and infinity in the denominator. It's an indeterminate form, air quotes. It's not really a thing. Okay, it can be almost anything. And so we use L'Hopital's rule. We employ it when we have plus or minus infinity over infinity, or when we have 0 over 0. Employ it how? How does it work? We take the derivative of the numerator and divide it by the derivative of the denominator and do that limit instead. So we get our 3 comes down, we get negative 2b squared. 2 comes down, we get, I think I wrote that wrong. Yes, I did. There's a mistake there. The 2 comes down, that's negative 8/3. Yeah, sorry about that. And then, yeah, still going to be negative infinity over infinity. Derivative again. So that's still going to be negative 8/3. Sorry about that typo. Still going to be negative infinity over infinity. One more time. And we'll have just a negative 4 over this exponential who's, getting the 3/2 every time. But anyway, yeah, negative 4 divided by something that's growing exponentially, it's going to head to 0. Okay. And so that all zeroes out. You're left with the final answer. We distributed this 27/16, is times in 0. And then the 27/16 we already distributed to the other part with the lower limit plugged in, and it canceled nicely. The mean, the average value, the expected value of this particular distribution is exactly 2. Okay. All righty. Good job.